All right, grade 11s. We're now going to look at some of the key concepts for grade 11 Trig. So starting off, we talk about the identities, which are kind of general rules that can be applied to certain sections in Trig. So one of them is tan. Tan theta is equal to sine theta over cos theta. Or if it's tan 20, it's sine 20 over cos 20. Or if you have squared, it will be sine squared over cos squared. And that's handy for when you want to replace a tan or replace a sine over cos and simplify a question. Then we also look at sine squared theta plus cos squared theta equals to 1. Now, provided that we have the theta and the squared and the squared, it will equal to 1. So it has to have matching angles and both must be squared before you can replace it with 1. Now in class you would have done the proof of this, which is needed for study purposes and to prove in an exam, but most of the time you just end up using the rules. What you can also do is rearrange the above identity by moving things across. So if you want to get rid of a cos squared theta, you can replace it with a 1 minus sine squared theta. Or if you have a sine squared theta, you can replace it with a 1 minus cos squared theta, which is going to help with the more complex problems to just simplify them later. Then moving on to the co-ratios. Co-ratios are talking about what we call complementary ratios, and it involves sine and cos. Now, complementary maths means adds up to 90. Like supplementary adds up to 180, complementary adds up to 90. So it's a relationship where the angle with sine and the angle with cos add up to 90, and they end up giving you the same value. So if you were to type sine 20 degrees into your calculator, you'd get an answer of 0.34. And if you were to type in cos 70 degrees, it also gets you 0.34. And that's because 20 and 70 add up to 90, and they are the complementary ratios of sine and cos. Alright, so we have generalized rules here that if you have sine 90 minus theta, it will get you a cos theta. So if you can link a relationship between sine and cos with 90 degrees, they can match up. So if you had sine 90 minus 20, for example, it will get you 90 minus 20 is cos 70. Same thing if you have angles bigger than 90, let's say 100 degrees, 90 plus 10 will get you 100, so cos 10 will end up being the same as sine 100. But we're going to look more at the reduction angles and reduction diagrams for that, for the bigger angles. For cos 90 minus, it gets you sine theta. For cos 90 plus, though, it gets you negative sine theta. And that goes back to the idea of the functions where we're shifting left and right. That one ends up looking like a reflected sine graph. But that's not something that is to be worried about for now. All you need to focus on is if you can see that sine and cos have a relationship of 90 degrees together, they are equivalent in value. Right, now looking at negative angles. If we were to look at the normal way we read a diagram off in Trig, we go anti-clockwise for our positive angles. So negative angles go clockwise. So we end up working with negative angles in what we deemed before cos's quadrant. So you have to ask yourself, if you have sine of a negative angle, what would happen in cos's quadrant? It would be negative because only cos is positive. So cos of a negative angle is going to be positive cos of that angle, and tan of a negative angle in cos's quadrant will be negative tan of that angle. So you pretend that you're in cos's quadrant when you're working with that. Even if it's not an acute angle, even if it's a big angle, you first deal with the negative angles.